So today we're going to talk about the appendicular skeleton. Now I'm down my mouse. I don't have my mouse. So we're going to do this the best we can. So I've removed the axial skeleton here. Okay, so the axial skeleton of the head, the skull, sternum, rib cage, sacrum, and vertebral column, they're all gone. And what we're left with is the appendicular skeleton. All of this hangs off of the axial skeleton. So we'll start at the top. Okay, and here we have the clavicle. Okay, I'm going to hide all of the other bones for a moment. Actually, we can just fade them away. Okay, so here we have our clavicle. Okay, and if we turn it up this way, you can see that it has an S shape to it. Okay, we have this nice swooping S curve. Okay. It goes from the manubrium of the sternum, and it goes all the way to the tip of the scapula. Okay, right there. And the two things that I want you to know about this, I want you to be able to tell me the different ends, right? So if this is laying on a table by itself, like that, okay, you should be able to tell me which end is touching the manubrium and which end touches the scapula, right? So we have names for those. Okay, so the part that touches the manubrium, that is called the sternal end. And on the other side, the part that touches the scapula is called the acromial end. Okay, this is obviously called the sternal end because it touches the sternum, the manubrium of the sternum. This is called the acromion end because this is called, this little joint here, okay, this is called the acromion joint. Okay, this is called the acromion joint, the joint that exists between the sternum, there we go, between the sternum and the, not the sternum, the clavicle and the scapula. Okay, that is called the AC joint or the acromion joint. Okay, the acromion end is much flatter. Okay, where the sternal end is much more roundish. Okay, and girthy. Okay, so that's what I want you to know if that was laying on a table by itself. Okay. The next thing that we want to talk about, let's talk about the scapula. Since we're there, we'll hide the other things away here. Okay, this is the scapula. Okay, you have two scapula. You have a right and left. This happens to be a right scapula. You need to be able to tell me if this is a right or a left scapula. And the way that you tell that is by knowing the markings. Okay, so we need to know a couple of markings on this scapula. Okay, this is the anterior part of the scapula. Okay, I know it's the anterior part, okay, because the anterior part has this long, let me get my pen, has this long marking here, and that's called a spine. Okay, that's the spine of the scapula. Okay, and the spine of the scapula is always on the posterior side. Okay, posterior. It's always on the posterior side. So if you pick up a scapula, or if you see a scapula on the table, you should automatically, first thing you look for is the spine of the scapula. That way you know it's the back, right? That should be pointing backwards if it was on a body, right? So in the anatomical position, it should be like this, okay? Now, we know that the arm has to fit in this area here. Right, that's where the arm goes. That's our shoulder joint. That's the ball and socket joint of our shoulder. So we know that has to sit there. And if the spine is on the back and this is the shoulder, then this must be a right arm. If you had this on a human being, it would be a right arm. And we can see that. If I reset, we can see that this is the right arm of this individual. Okay. That arm, why that's not working. The arm fits into this cavity here, okay, called the glenoid cavity, Okay, this space right here is called the glenoid cavity. And that's where the arm, or the humerus, the head of the humerus, which is what we're going to talk about next, that's where the head of the humerus is going to fit in and create the joint of the shoulder, right? So we have the acromion joint here where the clavicle touches the scapula. We have the shoulder joint here where the head of the humerus is going to attach to the glenoid cavity of the scapula. Okay, so that's what I want you to know about the scapula. If we move along, we move down to the humerus. Okay, here's our humerus. Okay, again, we need to know the different, if this is a right or a left humerus. Okay, so how are you going to do that? How are we going to figure that out? If this was by itself laying on a table, how would you figure out if this is a left or right humerus? Because you're going to have to do that, right? So the way you would do that is, again, you have to be able to orient yourself and know which side is the front or the anterior part and which side is the back. Okay, so if you turn this around and go to the back of the humerus, okay, see if I can zoom in here a little bit. Okay, here on where the elbow is, right in this spot. Okay, right here. Okay, that's where the ulna, one of your forearm bones, fits in to your humerus, and it's an indentation. You can see it a little better here. See how it indents? Okay, it indents right there, and we call that a fossa. Anytime you see an indentation like that, we call that a fossa or fossa. Okay, and that fossa is called the olecranon fossa. Okay, the olecranon fossa, and that's where the ulna will sit. And I'll show you when I put this back to, when I reset this back to normal, I'll show you how the ulna fits in that. But that's the back, okay? And the ulna kind of sweeps forwards in this direction, okay? Your arm only bends in this direction, right? Your arm doesn't bend backwards, right? So, see if I can get back to normal here. Okay. Ooh, too close, too close. There we go. Okay. Now, if we take a look at this elbow, we can see, let's do with the left elbow. We can see here how the ulna really fits into that olecranon process. Okay, right in here. Okay, that ulna, which is this bone right here, digs right in to that olecranon fossa. So if we turn the body back around and we take the humerus alone by itself again, okay, if we turn this bone around, that's our olecranon fossa. So we know that's the back, right? We know that's the posterior part of the arm. So the arm must be sitting in this direction if we're in the anatomical position. Now, how would you know if it's a left or right? You know the back and the front, but how do you know if it's a left or right? You know it's a left or right by looking at the head of the humerus. Okay, this is the head of the humerus. Okay, it's this big rounded ball that's going to fit into the shoulder and become the ball and socket joint of the shoulder. We know that the rest of the body is here, right? So this would be the sternum, here are my ribs, scapula's in the back, and that would be, the waist of the individual would be over here somewhere, the legs would be down here. This head of the humerus has to point medially, right? The head of the humerus always points medial to the individual. Okay, so if this was turned around, if we thought this was the back, right? If we thought this was the back, then you'd have to turn this arm around. Let's do that. Okay, if you thought, let's say you made a mistake and thought this was the back, okay, then this arm, or this humerus would have to point medially to the body, right? And it doesn't. This is the wrong side. So you have to know that the olecranon fossa is in the back. Okay, and once you know the olecranon fossa is in the back, right there, you can put it posterior, and then you can kind of imagine in your head, where would the rest of the body be, right? If this head had to go into a shoulder joint, okay, and then the shoulder's here, the clavicle's over here, the neck is up here, okay, we got our rib cage down here, okay, got a spine down the middle, okay, we know that this has to be a right arm, okay, and we'll take a look at this in lab when I have you, okay, so that is the humerus. Next, we'll go down to the forearms. Now the forearms, you have two bones in the forearms. You have a radius and you have an ulna. Okay, a radius and an ulna. One hint here that I always like to use is the word up. Okay, UP. Ulna is always going to be on the pinky side of the forearm. Okay, so whenever you think of where the ulna is going to be, it's always going to be on the pinky side, right? This is the thumb. Okay, it's digit 1, digit 2, digit 3, 4, 5. This is the thumb, and this is the pinky. Okay, so think ulna, pinky. Okay, ulna, pinky, up. Okay, the one on the other side is always the radius, and the same will go for the other side, the other arm. Okay, if you look at this side, okay, we can see that this is my ulna, and this is my pinky. And it's always on the same side. Here's the ulna, here's the pinky. Okay, the thumb side will always be the radius, but if you can remember up, ulna, and pinky, you'll be fine. Okay, now when you take a look at the ulna by itself, okay, it looks very, very different from a radius. So if we hide the other things, the ulna is very, very easily identifiable. And the thing that you want to use to identify the ulna is this piece right here. Let's see if I can get it. Okay, I'm just going to turn it to its side. Okay, so this is what it would be in the anatomical position. Let's reset. Let's just hit reset. That'll be easier. Okay, so there it is in the anatomical position. If I hide the other things and I give you like a lateral view, I just turn it a little to the side. This is the feature you want to look at, this big U shape here. Okay, again, it's a U for ulna. Okay, if you see that U, you see that big hook, then you know that that big U belongs to the ulna. It's telling you what it is, right? It's giving you the answer in itself. Okay, we call this, okay, just like the other thing in the back of the humerus was the olecranon fossa, this is the olecranon process. Okay, see if it'll, no, it doesn't highlight, that's okay, I'll just write it. Okay, olecranon process. And that olecranon process goes into the humerus, okay, into that olecranon fossa of the humerus. And I'll bring that back to normal here. Okay, so if we zoom out a little, let's go back up here. This, we turn the body a little bit, we'll turn it around, and we'll take a look at this ulna. Okay, here's the olecranon process right there. Okay, here's the olecranon process right here. Okay, that forms that big U shape, and that digs into that olecranon fossa, which is that cavity or that indentation on the humerus right there. Okay. The radius, okay, let's get this person back here. The radius is going to look very, very different. It's much smaller than the ulna, and it does not have a hook at the top. It has this like flat end. It's very identifiable. Okay, this is the head of the ulna. Okay, here's the head of the ulna. Okay, this is the proximal head of the ulna. The other one would be the distal head of the ulna, right? But this is the proximal head, and it has like this flat top to it. Okay, so it's pretty easily identifiable. Okay, and again, the radius goes with the thumb. The ulna goes with the radius. Okay. Now let's take a look at the hand. Same thing's going to be for both hands. I don't need you to know every single bone of the hand, but I do need you to know the groups of the bones. Okay, so we're going to have 3 groups of bones. We're going to have this group of bones. We're going to have this group of bones. Okay, and then we'll have this group of bones. Okay, so these are called the carpals. Okay, and those are going to be the bones of your wrist. Okay, these will be your metacarpals. Okay, metacarpals, and those are the bones of your palm. Okay, and these are going to be your phalanges. okay, which are going to be your digits slash fingers, right? We don't call the thumb a finger. We call all of these digits. This is digit number 1, digit number 2, 3, 4, and 5. Okay. Notice that digit 2 through 5 have 3 phalanges in them, right? This is the proximal phalange because it's closest to the body. This is the medial phalange, and this is the distal phalange. Okay, so distal, medial, proximal, and that goes for all of these. The thumb only has 2 phalanges. That's why we don't call it a finger. That's why we call it a thumb. Okay, but it still has 2 phalanges. It has a distal phalange, and it has a proximal phalange right there. Same thing's going to go for the other hand. Okay, in the anatomical position, the thumb is always lateral, right? Thumb is always going to be lateral. It's always going to be pointing laterally away from the body. Pinky will always be medial. Okay, so carpals, metacarpals of the palm, phalanges of the fingers and digits. Okay. If we take a look at the pelvis now, okay, let's take a look at the pelvis. Let's hide it from everything else. Okay, so the pelvis is actually made of 3 different bones. Okay, so you have 2 of these, right? 2 of these if we unhide the others. Okay, we take a look. You notice that you have 2 of these large bones here. You have one large pelvic bone here, another large pelvic bone here. Okay, when you talk about those individually, they are called coxa. Okay, this entire structure, this entire thing is called a coxa. Okay, that's why we named this the coxal region, right? So this is one coxa, and then you have the other coxa on the left-hand side. This is a right coxa. You have to know the difference, and the easy way for that is to know that this socket here is for your leg, and that always points laterally. I'll show you this in another moment. And this is the pubic bone, which is always going to point anteriorly. So if this is forwards, if this is anterior and this is lateral, then the leg, the foot must point this way, right? Your foot always points anterior. Your foot doesn't point towards the back of you. Your foot always points towards the front of you. So this must be a right leg, okay? But this coxa can be broken up into 3 major portions. Okay, this is the first portion, this green highlighted area. This is called the ilium, I-L-I-U-M. Okay, and again, you have another one on the other hip or on the other coxa. Okay, so it's this big area here on the top of the coxa. And we need to know that this big crest on the top, that is called your iliac crest. Okay, that we need to know. We also need to know about this big notch over here. Remember, we had a notch in the first axial skeleton when we talked about the mandibular notch. This notch is called the sciatic notch. And that sciatic notch deals with the sciatic nerve. Your sciatic nerve runs off of your sacrum, or out of your sacrum, and through your coxa, through this notch, so that it doesn't get impinged upon. Sometimes it does, and that's because of swelling of surrounding tissues. But typically that should not happen because of this notch. Okay, so we got the iliac crest and the sciatic notch. That sciatic notch is partially this bone as well, but we'll talk about that in a minute. Okay, so that's the ilium. Now, if we want to take a look at the anterior portion of the pelvis, okay, we have the pubic bone. Okay, this is the pubic bone. Okay, so now if this was in the right anatomical position, this person would be looking at us like this. So if we unhide the other ones, okay, we can see where that pubic bone sits in the rest of the body. Okay, it's called the pubic bone because it's in the pubic region. Okay, it is anterior. You can see that it's anterior. This is posterior where the sacrum is. Okay, so this is the pubis or the pubic bone. And one thing that I do want you to know about it, if we add the connective tissue, you can see that there's a pad of connective tissue right here in between the 2 pubic bones. And that is called the symphysis pubis, or the pubic symphysis. Okay, the pubic symphysis. And that is a piece of cartilage that holds or, keeps. It's a piece of padding essentially between the two coxa and in the pubic region. Okay, we don't want those two bones hitting each other. We want them to be protected, just like every other bone we have. Just like in between your vertebrae, you have cartilage, and in between here, you have a lot of times when females give birth. Okay, this pubic symphysis can split down the middle and then re-heal and fuse back together after the baby is born, and you can see that on an X-ray. Okay, so if a body is found, by a CSI group or a police force, they could help identify the body by taking X-rays of the pelvis if the soft tissue is still there. If it's just a skeleton, the soft tissue is going to be gone. Okay, but oops. Okay, yeah. If the soft tissue is gone, then you can't tell that. But if the body is still has soft tissue, they can X-ray it. They can see that if that woman had a child or not by looking at the symphysis pubis. Okay, and if there was a tear in it or not. Okay, so let's go back to the coxa. Okay, and we'll take the connective tissue out. Okay, we'll hide this again. And then there's one more portion of this pelvis. Actually, there's two more things I want you to know, but one with the posterior portion of this pelvis is called the ischium. Okay, and this is where your gluteus maximus would be. That's like where your butt is. That's the part you sit on. Okay, and that's the back portion of the pelvis. Okay, if we unhide this and we zoom out a little, you can see that is the rear portion, okay, where your derriere would be. And the last thing that I want you to know about this is, here's the joint of the hip. Okay, this is the hip joint. This whole thing is not your hips. Okay, that's one thing that a hip is a joint. A hip is not a bone, right? So this is your pelvis, right? All of these bones make up your pelvis. Okay, we call this the pelvic girdle. And this joint, where this femur meets up or articulates with the pelvis, okay, there are two parts to that joint. You have the femur part, which is called the head of the femur, and I'll talk about that in a moment. But you also have the pelvic part of that, which is called the acetabulum. Let's see if I can get that away. There we go. Okay, this indentation here, okay, I don't know if it will let me. Okay, here's the term acetabulum. Don't worry about the lunate articular surface. Just know that acetabulum is what I want you to know. Okay, acetabulum. So this entire area here, where the head of the femur sits into this ball and socket joint, is the acetabulum. Okay, I think I spelled that correctly. Yes, acetabulum. Okay, and that's where the head of the femur would sit. Okay, which brings me to the femur itself. Okay, so here's the femur. It's the biggest bone in the body. Okay, we hide things. We have a couple of things that we want to know here. Okay, one thing is we want to know the head as the head of the femur. Underneath the head, just like underneath your head, you have the neck of the femur. And a lot of times the neck of the femur is where this bone breaks. It's very hard to break the femur. Okay, it takes about 1 ton of force to break this bone. And if this is the weakest part, okay, the neck is definitely the weakest part of this bone. The center is extremely, extremely tough and dense. So typically when people break this bone, it's up here in the neck. A lot of times when people fall from a high distance and they put their legs down to try to brace themselves, the force goes up and that force looks for the weakest spot in the leg, and that's going to be the weakest spot. A lot of times people will, if they're in a car accident and if they see they're going to be in a head-on collision, they'll straighten their legs to kind of brace themselves, and the impact of that head-on collision forces energy up the leg, and again it breaks at the area of least resistance, which is going to be the neck. That's not to say you can't break it here. You can, right? If you get hit by a car and the car hits you dead in the middle of the leg, it'll crush your leg. If you fall off a mountain and you slam your leg against a boulder, it's going to break. Okay, but the majority of breaks happen up in the neck area. And two more things we want to know. There are things on the femur called trochanters, right? A trochanter is a very large prominence or a very large process on a bone, and you only have them in the femur. Okay, so they're only found in the femur. So here we're taking a look at the posterior part of the femur. Let's just spin it around to the anterior part or lateral view. Let's look at the lateral view here. Okay, this big bump here. Okay, that big bump. Let me turn it here. Okay, we see it again here. Here's this big bump on the lateral side of the femur. Okay, from the back side, it's here again. This big bump right here. That's called the greater trochanter. Okay, and the greater trochanter is only going to be found on the femur. There are no other trochanters, right? You have other crests, you have other spines, you have other foramen, you have lots of different processes and fosses all over the place, but trochanters only occur on the femur. All right, so that's the greater trochanter. Now, you see this term greater. They will only use terms like greater or superior or inferior or medial or lateral or maximus or minimus when there is an opposite. Okay, so if they go out of their way to say something is greater, then there must be something that's lesser, and that's this bump here on the back of the femur, on the posterior side of the femur. Okay, this is the lesser trochanter because it's smaller than the greater one. Okay, so you have your greater trochanter and your lesser trochanter. Okay, the big one and then the smaller one. Again, the lesser trochanter is still pretty big. Okay, but it's not nearly as big as the greater trochanter, and it looks like just a big bump. What are they for? They are for muscle attachments, right? So muscles, muscles of your thighs and your quads, and your legs and your pelvis and your back will all attach to these. Okay, we can even probably add some muscles just to show, okay, where these muscles are going to attach to. Okay, these are muscles of the legs. Add some more muscles. You can see how many muscles are attaching to the greater and lesser trochanters. There's another one. Okay, lots of muscles are attached to these greater and lesser trochanters, which is pretty neat. A lot of muscles there. Okay. Okay, let's bring everything back. Okay, let's zoom out a little bit. Then we go down here to the patella. Okay, the patella is your kneecap. This is called a sesamoid bone. Okay, see if I can write that here. Sesamoid bone. Okay, and then sesamoid just refers to the shape. It has this roundish seed-like shape, and it's called a sesamoid bone. Okay. And it sits in between your femur and your tibia, which is this bone down here, and it stops your leg from bending in the opposite direction, right? We only want the shin to go this way. We don't want the shin to go this way. That's a no-no. And that patella is going to act like kind of like a door jamb or a door stop, stopping the leg from bending in the wrong direction. Okay, next up is the tibia. Okay, make sure we spell these right. So we got the tibia here. Okay. And that is your shin bone. Okay. Whenever you get shin splints, it's on this very sharp line of the tibia in the front. That's where you would get it from. Okay. Behind it, you have the fibula. Okay, remember, it's tibia and fibula. Remember to spell those correctly. If you spell it tibula or fibia, it's wrong. Okay, so it's fibula and tibia. Okay, and then the last thing that we have, if I remember correctly, is the foot, which is very much like the hands. Okay, I don't know if it's going to let me highlight just the hand like it did with the and the other one. But we have three sections, the same exact thing. We have three sections. We have the tarsals, okay, which are the bones of your ankle, just like we had carpals, which were bones of your wrist. Then we have our metatarsals, metatarsals, and that's where like your shoelaces would be. Okay, if you had a shoe on, that's where your shoelaces would be. Like, see if I can draw a sneaker here. Okay, this is where your shoelaces would be. Okay, that's the tongue of the shoe. Okay, and then you have your phalanges. Okay, these are your phalanges. And we can see again that your toes have 3 phalanges each, except for your big toe, which only has 2 phalanges. Okay, but it's the same thing. It's going to be distal, medial, proximal for all of them, except for the big toe, which just has a distal and a proximal. So these are your phalanges. Same thing as the fingers or digits. Okay, the big toe is digit number 1, and then all the way to 5. Okay, so digit 1, 2, 3, 4, 5. Okay, so the big toe and your thumb are analogs. Your pinky toe and your pinky finger are analogs. And that is going to do it for the skeletal system, the axial and the appendicular skeleton. If you have any questions, please make sure to email me or put a comment in the video in the YouTube comment section, and I'll be glad to help you. All right, have a good one.